Now, with class 8, to start, we're gonna explain the binomial theorem. To continue with the IB Mathematics standard level course. So, the binomial theorem. Let's say we're having x plus 4, all of it squared, and we want to expand this expression. How do we expand it? First, we take the first term and we square it, plus 2 times the first term times the second term, plus the last term, which is the second term squared. Simple as easy, and easy because we've taken it before and we can memorize this. It's easy to expand this expression, but what if we have an expression like this? I want x plus 4 to the power of 5 or to the power of 6. What if I'm having 5 or 6? Maybe I can expand it if I'm having to the power of 5 or to the power of, but what if it was to the power of 12 or to the power of 13? So to expand expressions, we need to use the binomial theorem. The binomial theorem, what does it say? The binomial theorem. If I have a plus b, all of it to the power of n, and I want to expand it. So the expansion of a plus b, all of it to the power of n, is the summation from r equal to 0 to n for the combination n with r, a to the power of n minus r times b to the power of r. This formula, honestly, it looks complicated, but once we explain it further and we take examples, it's gonna be so easy. So, this is how I can expand any expression. For the n combination r, to expand this combination or to find its values, it's equal to n factorial over r factorial times n minus r, all of it factorial. Factorial means is like, if I have an example, if I have 3 factorial, this is equal to 3 times 2 times 1. If I have 5 factorial, the 5 factorial is equal to 5 times 4 times 3 times 2 times 1. So now let's take an example and expand it in this way. If I have 2x plus y, all of it to the power of 4, and I want to expand this expression. As we've said before, we need to use the combinations and whatever. So I can consider the 2x to be my a, the y is the b, and the 4 is the n. So to expand it, it's equal to, I need 4 combination 0, 2x to the power of 4 times y, which is b, to the power of 0, plus 4 combination 1 times 2x to the power of 3 times y to the power of 1. This is n combination r. 2x to the power of 4 minus 0. That's why I have in 4 and I'm having this is 0. Plus, I reach now, it's 4 combination 2, 2x to the power of 4 minus 2 times y to the power of 2, plus 4 combination 3, 2x to the power of 1, which is 4 minus 3 times y to the power of 3, plus 4 combination 4, 2x to the power of 0 times y to the power of 4. To find the value of the combination, let's say I want to find the value of this one for combination 2. To find the value of the combination 4, combination 2, I use on the calculator NCR. Now we can see how we can find the value. For combination 2, let's look at our GDC. We started, clear. We want 4, combination 2. So we press the 4, then to find the combination, it's called NCR. We go to math, we go to probability, and the NCR is the third choice, so we press 3. So I'm having now 4 NCR, and now easily I have to press the 2. So now I'm having 4 combination 2, and the calculator is 4 NCR2, and it gives me a 6. This value is 6. This is for now all about the binomial theorem. We use this theory to solve questions from the question bank, previous exams. Maybe the questions would be on a higher level, but now we'll solve 2 examples, so you are ready to go and for your exams. Let's see example 1. In the expansion of ax cubed times 2 plus ax, all of it to the power of 11, the coefficient of the term in x to the power of 5 is 11,880. Find the value of a. Now, I'm having a x to the power of 3 multiplied by 2 plus ax, all of it to the power of 11. So, in order to get a final value or the term having x to the power of 5, I need to multiply this ax to the power of 3 times x squared, so I can get x to the power of 5. So now I need to find the term containing x squared in the expansion of this binomial. So to get the x squared here, I need 11 combination 2, 2 to the power of 9 times ax, all of it squared. By this I can get the x squared, but I need to find the coefficient of x here. I need to find 11 combination 2 times 2 to the power of 9. We go to our GDC. Now 11, I go math, PRB, then I go choice 3, which is NCR. 11 NCR 2. It's 55. 55, I need to multiply it by 2 to the power of 9. This is 2 to the power of 9. I'm having 28,160. So this value is 28,160 times a squared x squared. So now the coefficient of x squared is 28,160 a squared. This is my coefficient of x squared. So I need to multiply this value by ax cubed to know the coefficient of x to the power of 5. Let's multiply them. I have ax to the power of 3 times 28,160 a squared x squared. It gives me 28,160 a cubed x to the power of 5. So now the coefficient of x to the power of 5 is this, and it's given in the question that the coefficient is equivalent to 11,880. So I equate them together. I have 28,160 a cubed is equal to 11,880. I divide by 28,160, 28,160. They cross out, so I'm having a cubed is equal to 11,880 over 28160. So A is equal to the cubic root of this value, which is 11880 over 28160. We have to use our GDC to find this value. So we go to math as well to find the cubic root. It's choice number 4. I go to 4. I'm having a bracket. It's the cubic root of 11880 divided by 28160. I close the bracket. And is equal to 0.75. The value of A is equal to 0.75, which is equal to 3 over 4. Whatever you can write it, either as 0.75 or 3 over 4. Both ways are correct. The most important thing to know is we have to give most of our answers to 3 significant figures. This is example 1. Now we can go to a harder example. Example 2, consider the expansion of x squared plus 2 over x, all of it to the power of 10. Part A, write down the number of terms of this expression. The number of terms is always 1 more than n. So the number of terms here is equal to 10 plus 1. So number of terms, this is n is 10. So number of terms is equal to 11. Always you take the n and you add 1. Easy. Let's go to part B. We need to find the coefficient of x to the power of 8. So we have to find the term that gives me x to the power of 8 in this expansion. So we can go to, we say I'm having 10. I know the 10 because it's the n, but I don't know r. So I keep r as unknown. 10 combination r, x squared, all of it, to the power of 10 minus r, times 2 over x to the power of r. And this must give me the coefficient of x to the power of 8. So now, in order to find r that gives me x to the power of 8, I must neglect the constants at first. So I neglect this value and I neglect the 2 here. So it becomes x to the power of 20 minus 2r times x to the power of minus r, because I've taken the x outside. It must be give me x to the power of 8. So if we cancel the x's, we cancel out the x's, we'll have 20 minus 3r is equal to 8, having r equal to 12 over 3, which is equal to 4. Now I find the value of my r. After finding the value of my r, I need only to substitute it here to find the coefficient of x to the power of 8. So it becomes 10 combination 4 times x squared, all of it, to the power of 6 times 2 over x to the power of 4. And since here I only need the coefficient, so I neglect the x's, I neglect this x and I neglect this x. So my coefficient would be, having my coefficient is 10 combination r times 2 to the power of 4, which is equal to, I need also to use my GDC here. So I go 10, I go math, PRP, and I press 3, 10 combination 4 is equal to, and I multiply this value by 2 to the power of 4. It's equal to 3,360. This is the coefficient of x to the power of 8. Equal to 3,360. This is my coefficient. This topic is not big, but it's essential and important. Many questions in your external examinations will be coming on this topic, so practice well